Hello. In this video, we will demonstrate a model fine-tuned over the base model that we open sourced as part of the OpenHathi effort. The OpenHathi series is meant to be a series of open source contributions in models and data sets for Indian language AI, specifically focusing on generative AI. It's a collaboration between Sarvam and our academic partners, AI for Bharat, which contributed language resources and also independently benchmarked the model. We really hope that the ecosystem can take what we have shared. In fact, we have shared a very detailed technical blog of what we have done, and the ecosystem is able to replicate it, innovate on top, and take things further. We at Sarvam are also going to be training at much larger scales and releasing them as part of our platform, which will launch soon. But we wanted to share the excitement and show you what is possible today. I can go here and I can type something like write an essay in Hindi about the natural beauty and diversity of India, right? And now it starts generating a response in Hindi. It is talking about the vegetation. It is talking about the animals here. It is talking about maybe the landscapes here, and it's also talking about the rivers and lakes, and ends with a conclusion about what it is. Notice here that there are some statistics on the bottom. It, for example, tells you that we have generated this with about 254 tokens. But if I were to copy this now and paste it in the GPT tokenizer interface, which is a tokenizer that is used both in GPT 3.5 and 4 models, then you will find that the number of tokens here is much, much larger, right? And this is primarily because, as you see here, the Indian language characters are not modeled, and the model is falling back on Unicode, which sometimes consumes more than one token per character. And if I do the same thing for the Llama tokenizer as well, you should see the number of tokens is much larger. In fact, larger than even the OpenAI tokenizer. So what we have done by adding a new set of tokens in the base Llama model, we have made both the representation of input in Hindi and the generated output in Hindi much more efficient. And as you know, number of tokens affects the latency, but also affects the cost of inferencing. So this is one critical advantage of customizing an existing model for a new language, in this case, Hindi. Let me do something a bit more commonplace. Let me say, write in Hindi the recipe of palak paneer. So it now says that it's a popular dish. It gives me the ingredients and it gives some instructions. Yeah, so that looks like a reasonable answer. In some cases, the model, having seen so much more text in English, might be able to perform better when generating the response in English, but we may need the answer in Hindi. So one way to do that is to think in English and then respond in Hindi. So I'll show you an example of this. So if I said, write a conversation between Harry Potter and Hanuman, right? This is what these models are capable of helping us with. And they both discuss devotion. Hanuman shares some deep insight, let us say, based on his devotion to Lord Ram, and Harry connects to his love for his parents. And here is the critical thing. If I just left it like this, it will generate an answer in English. But I can say, first, write in English, and then translate to Hindi. The model will now follow this instruction. It's first answering in English. It's writing a dialogue. They are greeting each other. Then Hanuman says, I want to talk about devotion. Harry Potter says, sure. Hanuman says, devotion is a deep and pure love towards something, someone or something. It involves selfless service and complete surrender to the object of one's devotion. Can you give an example? Lord Ram was my guru, and I devoted myself entirely to him. I served him with all my heart and soul without any expectation of reward. This kind of devotion is called bhakti. And Harry Potter says, wow. And it goes on, right? So my parents were my gurus is what Harry Potter says, and that's wonderful. Love and sacrifice are indeed the sense of devotion. And notice here Harry Potter said in the past tense, which shows that the model knows that his parents are not around. So it's an interesting conversation. And look at this; it now starts translating to Hindi, and it writes now the same. It does a good job of translating whatever is there in this part of the English output into Hindi. This is when the fact that the English model has seen so much text, perhaps a lot of discussions about Harry Potter's story, it's able to inherit that and write this kind of a conversation. And the model is now able to generate that also in Hindi. It's completed. Again, it's about 569 tokens, though this is a very long output. I can copy this again and maybe go to the Llama tokenizer in this case, paste it, and we see that there are far more number of tokens if you generated this. Even if you were to throw away the English, which is an attempt at chain of thought thinking in some sense by us, if you were to delete that and just look at the Hindi output. If you just generated this in Hindi, it would be even then far more number of tokens than what we are generating in both the languages, right? So this is an example of generating text in Hindi and when required also generating in English and taking the advantage of the efficient tokenizer to be very efficient at doing that. Now let's look at some examples where there is some context coming from an external source, which can come from templates like RAG, for example, retrieval augmented generation, where semantic search is done, or maybe there is some context of a user profile or a particular content that the user is interacting with, and that is available in the conversations context. So I have opened a few such examples. This is, for example, the website of NCERT, which contains the books for various standards and for various subjects. I can take maybe this until here. Okay. I can copy this entire thing here and I can paste it here and then say answer the following based on the above context, right? And I'm going to look quickly in this. This talks about constellations. Notice I want to do this cross-lingually, though the English content is available in the context, which is often the case. There's a lot more content in English, and semantic search is also very efficient and accurate. But I might want to interact cross-lingually with it. So I might want to say constellation kya hai. And notice I'm using the Romanized form of typing, which is very common in India when using a QWERTY keyboard like on the laptop I'm using now, but also on mobile phones. And the model says constellation is a group of stars that form patterns in the sky. And this is what this particular document is also saying. This also has something about planets and how the etymology of planets comes from. Let me showcase doing this with Hindi text. So let me just open Google Translate. And say what is the origin of the word planet and graha shabd ki utpatti kya hai. So it should understand words like utpatti. So I can copy that and I can paste it here and it continues the conversational context and it says correctly the word planet comes from the Greek word plantae, which means wanderers. So we feel this is very important, the ability for people to ask questions cross-lingually. And finally, if I ask also in English, if I said what does the passage say about the weight of the moon? This is an example where the passage does not have information. It had something about moons at the bottom, but notice that it's very, very limited. And it does not, of course, talk about weight. So one of the important aspects about grounding the answer on a given context is to be able to not answer it if the information is not there, which is what we have trained the model to do. So this is one example. This is in the educational context, which we think will be very useful in India's context. But let's take one more. I have opened here a website of Vikaspedia, which contains various government-related documents. For example, this is something about the rights of power consumers in the country. So I can copy this whole thing. It's a pretty long document. And often these are kinds of things that people find very hard to read and understand. So I can again say answer the following based on the above context. And I can ask, for example, this is about electricity. So let's say I asked it in Romanized form, agar mujhe connection close karna ho, to policy kya कहती है. Right? So what does the policy say if I want to close my connection? The policy states that in the case consumer desires that his meter to be permanently disconnected, he shall apply for the same to the distribution licensee, and the licensee shall arrange for a special meter reading and prepare a final bill. the disconnection shall be done immediately after payment of the final bill, right? So first of all, notice that it sort of connects to my question. I asked what does the policy say, and the policy states is how the billing begins, and it grounds the answer based on what is there. I can a little bit try one more example. I could say senior citizens के बारे में policy क्या कहती है. What does it say about senior citizen? It states that the distribution licensee should provide all services such as application, submission, payment of bills, etc. to senior citizens at their doorsteps, right? So we have policies like this which provide benefits for sections of society, and making that accessible to people is useful. And let me do one more. Maybe I can again try this translation approach. I can say, what are the facilities for making a complaint? And let me ask you to respond in Hindi this time, right? So respond in Hindi, because it's been responding in English, but you may say this. I can paste it here. And it says नीति ने कहा है कि उपभोक्ता शिकायत निवारण मंच CGRF में उपभोक्ता और उत्पादक प्रतिनिधियों का शामिल किया जाएगा, right? So there is some kind of a forum where people can do some grievance redressal, I suppose, right? So this is what it answers a question also in Hindi. Let's do one more, this time taking a slightly different domain. So this is the Bletchley Declaration that was done very recently in the AI Safety Summit. It's a very long piece of text, so I can copy this whole piece of text. It's maybe until here, and I can create a new conversation. And here, let us say, instead of asking questions, right, which is probably one way of doing it, but I might just say, summarize the above in Hindi in bullet points, right? And in this case, it's a complex and long piece of text, but now I'm able to generate more succinct and also itemized view in Hindi. Let's just read one of them. AI मानव कल्याण शांति और समृद्धि को बदलने की क्षमता के साथ एक महत्वपूर्ण वैश्विक अवसर प्रस्तुत करता है. AI presents an opportunity to create humanitarian good, peace, and prosperity, and so on. So notice that such a big piece of text was compressed into a much shorter, more accessible text like this. So we believe that this will form a key usage pattern of these models, where content is available at scale with diversity in English, but people would like to cross-lingually access it. Let's talk about translation, which has been a very important part of Indian language AI because it enables much more content to be accessible by more people. So if I open something like the Wikipedia page for India, and I take the first paragraph and I paste it here, and I say translate the above to Hindi, now it goes ahead and it translates this. Notice that it is making some interesting choices here. It says India officially the Republic of India, India Bharat आधिकारिक तौर पर भारत का राज्य, and then it retains this bracket which gives the ISO variant of Republic of India as it is, right? And it also does not trip when it sees things like citations, which tends to affect some of the older generation domain-specific models. In fact, it adds a space to make it more readable, and generally does a very good job of translation. We have compared it on benchmarks with state-of-the-art models, and on English to Hindi direction, which is this one, we are matching the state-of-the-art systems. Plus, there are some additional advantages like what we discussed. But this is for fairly simple text, but often text can also be more complex. One source of complex text is, of course, scientific documents. Here I have the GPT-4 technical report open. And if you take a sentence like this one, right, which talks about GPT beating other large language models, and there are some complex phrases there. So I can again do this and say, translate the above to Hindi, and in this case it says पारंपरिक NLP benchmark के एक suite पर GPT-4 पिछले बड़े भाषा मॉडल और अधिकांश अत्याधुनिक प्रणालियों जो अक्सर बेंचमार्क विशिष्ट प्रशिक्षण या हाथ इंजीनियरिंग करते हैं दोनों को पछाड़ देता है. It uses an interesting phrase, पछाड़ देता है, for outperforms. That maybe one could change that, but roughly this is how literal translation would work. It maintains context, it maintains things within the brackets and so on. But let us say if you wanted to do differently, if you wanted to make this context more accessible to people, so instead of saying translate the above to Hindi, I could say translate the above literally to Hindi, analyze the complexity, and then simplify it. Right? So it provides a literal translation. GPT-4 ने पारंपरिक NLP benchmark के एक suite पर. This is similar to what it did, but of course it used now पीछे छोड़ दिया instead of पछाड़ दिया. That's a bit of a better phrasing. And now it is trying to analyze what it can simplify about it, and realizes that things like NLP benchmark, state-of-the-art systems should be simplified. And let's see what it did. Firstly, notice that it used GPT-4 in much more readable भाषा model प्रशिक्षण के एक set पर. Instead of using suite, it used set. पर पिछले बड़े भाषा मॉडल और अधिकांश आधुनिक भाषा मॉडलों जो अक्सर विशेष प्रशिक्षण या कस्टमाइजेशन करते हैं, इंस्टेड ऑफ सेइंग हैंड इंजीनियरिंग इट यूज कस्टमाइजेशन, दोनों को पीछे छोड़ दिया. सो आई वुड प्रेफर एज एन इंडिविजुअल टू रीड a translation that looks like this, and there might be applications of this not just in technical content, but other sources like legal content, maybe medical jargon, and so on. And we genuinely believe that if you use large language models, the notion of what translation is, which is to make information accessible to people, could change. I could also, of course, show other directions. One of the important things is we have built the ability to translate from a Romanized form of Hindi to English. So, for example, I could say, translate the following to English, and I can write a Romanized thing. Let us say something, let's in a customer care kind of a setting, I could say, Mera parcel nahi aaya hai. My parcel is not arrived yet. And मैं बहुत दिनों से वेट कर रहा हूँ और अभी अपना ऑर्डर कैंसिल करना चाहता हूँ with a full refund, right? This is the kind of thing that people would write. It's code mixed, it's Romanized, but now the translation is very good. My parcel has not arrived, full stop. I have been waiting for a long time, comma, and now want to cancel my order with full refund. Notice that I was, of course, code mixing here, and all that works quite well. You can also, of course, do translation from Hindi to English. So I have taken this recent news from Daily Hunt, a news channel. I can take maybe the first sentence of this, and I can say, translate the following to English, and paste this. It says अंतर्राष्ट्रीय बाजार में कच्चे तेल की कीमतें आज लगभग सपाट बनी हुई है. So it says the international price of crude oil has remained almost flat today, right? So it does a good job of translating. One interesting thing about this is that if I were to copy this, even if the input had some errors, right? Let us say I removed the space here, I removed the space here. These are, of course, not correct words, and maybe a space here, maybe a space on this one, last one, and still the model understands it, right? It is this is again the benefit of using a large language model, which understands things more generally than a domain-specific model. It is able to tokenize it, and even if there are errors in the tokenization, able to translate it. And this might be useful when, let us say, trying to digitize content from documents where OCR sometimes misses spaces, but we would like to still analyze it. So this concludes our presentation. We have showed you different ways in which this model is useful. Again, we look forward to innovation on top of this base model, and we look forward to people using these models on the Servon platform.